5.2, Triangle Congruence. Congruent triangles have the same size and shape. Now, any congruent figure has the same size and shape, and we know that. So this means all corresponding parts are congruent. What are the corresponding parts? Both sides and angles. So when triangles are congruent, we can write a congruency, excuse me, a congruency statement. A valid congruency statement must match all corresponding sides and angles. So in other words, order matters. In this one, I said that A is congruent to D, and look, I have marked this with just one mark for congruent, then two for a different one, three, etc. So I've marked all the corresponding sides. So a valid congruency statement matches the parts that are congruent. I can name the first triangle in any order I want to. So I'll say ABC. The second one has to match. So which angle is congruent to A? It's D. So I'm going to start with D. Which one's congruent to B? Is E, and C is F. Now, excuse me, I have the hiccups. I could also do it in a different order. I could do BCA. And then I have to match it up. B with E, C with F, A with D. And then I could do, maybe just do it backwards. CBA is congruent to FED. But I have to, if I'm saying they're congruent, I'm matching the congruent parts. So then I have this fun theorem called CPCTC. It stands for corresponding parts of congruent triangles, CPCT, are congruent. There's your last C. CPCTC, corresponding parts of congruent triangles are congruent. So if you know they're congruent, if I give you a congruency statement, then you know their corresponding parts are also congruent. So let's do an example here. If I want to list all the parts, so I've given you the statement, so it's telling you the corresponding parts. So in the first triangle, I have angle J. It's congruent to, which one's in the same order? Angle P. Angle K is congruent to angle Q because they're both in the middle of that congruency statement. And angle L is congruent to angle R because they're both at the end of the congruency statement. So we do this also with the sides. I could look at side JK. It's the first two letters, so it's going to be congruent to the first two letters over there. PQ. KL is congruent to QR. And then let's do the first and third. JL is congruent to first and third of the other one, PR. Now, if I ask you to write another valid congruency statement, so let's take it in a different order. I might just do it backwards. That's easy to do. So LKJ is congruent to RQP. You just have to keep corresponding parts in the same order. So then let's skip number 3. Let's look at example 4. Here's my congruency statement. So find the missing measure. So BN right here, first and third, is congruent to SW, first and third. So this is also 9 centimeters. TW is congruent to FN, so it's 14 centimeters. And BF is congruent to ST, which is 17 centimeters. And W's last, so it's congruent to N, so it's 82. B is first, so it's congruent to S, which is 67. And then F, the one left, is going to be congruent to T. I don't know what they are. So the way I find them, I have enough information because I know that the 3 angles of a triangle always add to 180. So I'm going to add these 2 and take from 180 and get 31 degrees. Then let's jump down and look at example 6. UV right here is congruent to TS right here. So 12x minus 7 is 53. So I have to line up the parts in the right way. I'm going to add 7, and I'm going to divide by 12. So x is 5. And then I'm going to set up another one. Let's look at, where's my y? Right here. RS is congruent to VW. So 5y minus 33 equals 57. I'm going to add the 33. That didn't look very nice. 90, divide by 5. And let me just make sure I did the math right. I did. So y is 18 because 5 goes into 90 18 times. And then let's do z. So z has to be the one that's left. 3z plus 14 equals 50. So I'm going to take away the 14. 3z equals 36. Divide by 3, and z equals 12. So use your CPC-TC information to solve those.